Hey, welcome to another of our fantastical, far-reaching, and yet comfortingly hypothetical trips through our world and beyond. Today's marathon of what-if scenarios includes, of course, a look at several thousand different ways that our universe could decide to end us, or unalive us, as the kids say. We'll get hit by asteroids, come face to face with dinosaurs and Titanoboa, detonate an antimatter bomb, a nuclear bomb, and get enslaved by aliens. I'm specifically not looking forward to that one. And of course, we encounter a couple black holes along our journey. Any of that sound exciting to you? I mean, it's exciting in the sense that it excites the senses and makes my heart race, but I'm not really excited to see the end of humanity, and thus myself. Although, yeah, there is a certain morbid curiosity that I think we all have in seeing the mechanics of the various ways we could bite it. Anywho, enough rambling. Let's split these scenarios into categories. There's the threats we face from earthly disasters like volcanoes and earthquakes, and the outside threat of alien invaders from space. Of course, the man-made chaos, since we don't have enough sense not to put our own species in mortal danger, and the killer creatures that could eat us alive. You still with us? Great, we can get through this together, you and me. Just take a couple of deep breaths, repeat your mantra a few times, and let's blast off. First, to the cosmos, infinity and beyond, as we attempt to not get sucked into a black hole. Could a black hole devour us all one day? There are millions of them out there, just waiting. And if we happened to make a black hole accidentally, well, you better fasten your seatbelts. Things are really going to suck. Literally. What would we see if we got pulled into a black hole? Could Earth orbit the sun and a black hole? And would we survive spaghettification? This is What If, and here's what would happen if Earth were sucked into a black hole. Just 3,000 light years from Earth is a black hole visible to the naked eye. Thankfully, we're a safe distance from this stellar black hole and many others like it. There are approximately 100 million of them out there in our galaxy that we know of. They are remnants of supernovae, which occur when stars 10 to 20 times larger than our sun collapse in on themselves. Stellar black holes are fairly common and are about 16 kilometers in diameter. And then there's the much larger competition. Supermassive black holes. These have a diameter roughly the size of our solar system and a mass greater than 1 million suns combined. One of them, known as Sagittarius A, is right smack dab in the middle of our galaxy. So, how close would a black hole need to be a danger to us? Well, technically, a black hole the size of a 1 millimeter pin could destroy us if it was close enough to Earth due to its incredibly dense mass and extreme gravitational pull. Our survival all depends on whether we've surpassed the event horizon or not. You can think of this as the black hole's point of no return. Anything beyond this point would have to travel faster than light to escape. Yeah, good luck with that. If Earth got close enough, the side nearest to the black hole would begin stretching toward it. Our atmosphere would start to be vacuumed up, and then huge chunks of the Earth would rip apart and follow suit. If Earth managed to fall into the orbit of the black hole, we'd experience tidal heating. The strong, uneven gravitational pull on Earth would continuously deform the planet. This would generate a tremendous amount of internal friction, heating the Earth's core to disastrous levels. It would likely give rise to earthquakes, volcanoes, and deadly tsunamis. The trifecta of doom. Eventually, Earth would begin to stretch in a process known as spaghettification. And not in the tasty, cheesy, tomatoey way.
Mamma mia!
Let's say you were a superhero and decided to fight the black hole head first. Well, your arms would be closer than your feet, causing your body to stretch out vertically and become more and more compressed. Let's hope your superpower is elasticity. For an average-sized stellar black hole, spaghettification can occur several hundred kilometers away from the event horizon. But for a supermassive black hole, physicists believe that this would happen inside the event horizon due to its size. Eventually, no matter what size it is, anything entering a black hole would be ripped into a string of individual atoms. This would happen to anything that crosses it. People, planets, stars, you name it. Unfortunately, our whole solar system would be doomed. The careful balance of the sun and our many planets would collapse, which could send them crashing into one another. And to add insult to injury, our asteroid belt would get sucked toward us. About 200 of the 552,894 asteroids we know of are more than 100 kilometers across. So, if one hits us, we'd be dead before we would turn into spaghetti. Frankly, I'm not sure which fate would be worse. All of the matter in our solar system would join the accretion disk around the black hole. As matter gets sucked into the black hole, it generates massive amounts of radiation, so even if we somehow survived all the asteroids, we'd likely die from the radiation. Believe it or not, astronomers have discovered rare circumbinary planets that orbit two stars. While this may be a possibility with a black hole and our sun, the extreme tidal forces would likely make our planet uninhabitable. And worse yet, we might get kicked out of orbit or swallowed by the sun or the black hole eventually. Sorry, but there's not an outcome where we win here. But, and this is a big but, maybe we could find a way to protect ourselves in some hyper-reinforced space shuttle. If we somehow made it past the event horizon, we might be in for an even stranger time. Physics as we know it would change. Things like gravity, the speed of light, and even how atoms bind and react may be completely different. The truth is, we don't know what would happen. We can't get any information out of a black hole. Mars has been on a direct collision course with Earth for weeks now. The destruction has already started with massive tsunamis and earthquakes. Now, our planet is beginning to crack and gravity is significantly changing. But how bad will this be? How could it create a new planet? And is there any way humans could survive? This is What If, and here's what would happen if Earth collided with Mars. 15 days before impact. This won't be the first time Earth has had to deal with a massive collision. Over millions of years, asteroids have rained down on our planet. One of the biggest, the asteroid that wiped out the dinosaurs 66 million years ago. Now, despite its massive impact on Earth and our history, that asteroid was only 10 kilometers wide, about the size of 90 football fields. Mars, on the other hand, has a diameter of 6,800 kilometers, and it's coming straight at us. The red planet is normally about 225 kilometers away from us, but at this moment, it's just 4 million kilometers away. From this distance, it looks like a smaller red moon is approaching us. Now, just because it hasn't made impact yet, doesn't mean we won't be feeling any of its effects. The moon affects the Earth's tides, so what happens when another massive celestial body comes near our planet? Well, the gravitational force would be so strong that Earth's crust would start to bulge and our water would be rising. It could rise so violently that multiple tsunamis become a real possibility. More on that in a bit. 3 days before impact. Okay, now at just 800,000 kilometers away, Mars is twice as far away from Earth as the Moon is. Given its angle of approach to Earth, we'd be looking at a red half moon getting bigger and bigger by the minute. But the red planet is 10 times heavier than the Moon and is already tugging at everything on Earth with much greater force than the Moon could even dream of. It's creating havoc. At this point, tides are rising 30 to 50 meters high. Deep inside Earth, tectonic plates begin to shift and creak, but it's gonna get much worse. In 36 hours, Mars will reach the same distance away from Earth as the Moon. Then, the tides will rise 10 times higher than usual, 60 to 100 meters. Vast stretches of coastal areas and cities would be flooded. Say goodbye to Miami, Venice, and any other city near a large body of water. Millions of people will drown. There'll be widespread panic as people on Earth see Mars's relentless approach. Earth is starting to crack. Earthquakes shake the globe. Volcanoes erupt, covering the surrounding landscape in hot, molten lava. People are running for underground bunkers, grabbing any power source available. Will they make it? Well, getting emergency assistance to one disaster site is challenging enough. Now, imagine trying to do that when you've got countless disaster sites, many in remote locations. And, oh yeah, most of the planet is without power because this incoming collision has wiped out our infrastructure. Fun times, right? Well, thankfully, before the big crash, some great minds were already cooking up a solution. One company called Nano-Nuclear Technology has been developing these fantastic microreactors. These tiny powerhouses can produce between 1 and 20 megawatts of thermal energy that can be used as heat or converted to electricity. Microreactors can be deployed and removed quickly, making them perfect for emergencies. But here's where it gets even cooler. Nano-Nuclear isn't just developing any old microreactors. Hailing from Mount Olympus and Valhalla, their projects are Zeus and Odin. I guess when you're dealing with world-changing tech, you name them after Greek and Norse gods, right? Zeus, the solid core battery reactor, and Odin, the low-pressure coolant reactor, are the perfect duo to save us from this doomsday scenario. But we don't need to go to these extremes to see their benefits. You see, these microreactors are helping us tackle real crises today. Their small size and portability make them perfect for remote communities that lack access to the central power grid. Plus, they can help our fight against arguably our biggest crisis right now, climate change. Microreactors can significantly reduce emissions from electricity production by providing a zero-carbon alternative to coal, oil, and natural gas plants, ensuring a steady power supply without the intermittency issues of solar and wind energy. But nano-nuclear energy isn't stopping there. They're thinking big by going small. They're working on becoming a vertically integrated company, covering everything from cutting-edge portable microreactor technology to nuclear fuel fabrication and transportation. Talk about covering all your bases. Now, if you want to learn more about how nano-nuclear technology is changing the world and fighting climate change, well, check out nanonuclearenergy.com. But hey, maybe climate change isn't our biggest worry right now because we have another planet crashing into us. So let's get back to that, shall we? 4.6 billion years ago. Okay, wait a minute. Before we get into what happens next to Earth, how did we get here? What sent Mars hurtling toward us in the first place? Well, Mars could have been pushed out of its orbit by a rogue planet. This is a planet that exists without orbiting a star. There are billions of these kinds of planets roaming around our universe. They're sometimes hard to detect, though. Why? Well, because they don't give off a huge amount of light, and the light they do reflect is at wavelengths that are incredibly hard to detect. So, it's possible a rogue planet could have entered the solar system undetected, shoved Mars from its current orbit, and here we are. And like I said earlier, it's not the first time a planet the size of Mars has collided with Earth. About 4.5 billion years ago, just after the solar system formed, baby Earth and a Mars-sized planet crashed into each other. You can see it today. The debris from the collision eventually formed the Moon. At this point, people on Earth are in a frenzy, trying to find shelter from this terrifying catastrophe. But violent quakes shake the ground and toss people about. Tsunamis rage and millions of people are drowning. Wherever they can, people are running to underground shelters, hoping for some level of protection. Mars is just 10,000 kilometers away. The gravitational force of Mars and Earth are pulling at each other intensely. Mars is starting to pick up speed, reaching 10 kilometers per second. What's happening now is incredibly interesting. As it's making its way toward Earth, Mars is starting to crack. Why? Well, Earth has 10 times the mass of Mars, and because of this, our planet is exerting gravitational pressure on Mars, causing it to break. Now, there is a possibility that Mars crumbles entirely from this pressure. Maybe the people of Earth live to see another day, but unfortunately that's not likely to happen. Because Mars is moving so fast, there's not enough time for Earth to break the red planet apart. What happens next isn't going to be pretty. 20 seconds before impact. If you looked up now, Mars would be filling up nearly the whole sky. It's now just 200 kilometers above Earth's surface. It's entered the upper reaches of Earth's atmosphere. An enormous shock wave has hit the atmosphere. Due to this, you're finding it hard to breathe. Mars's gravity is pulling at our atmosphere. But that's nothing compared to what's coming next. Cracks in the surface of the Earth will be widening, creating massive canyons. The biggest earthquakes ever don't hold a candle to this. Buildings crumble and entire cities will be reduced to rubble. If you're on Earth as this is happening, well, there's not much you can do. Just hold tight for what's about to happen. Moment of impact. As Mars makes contact with Earth's surface, gravity will be about 30% of what it usually is on the side of the Earth where the crash happens. That's because Mars's gravity is 40% of Earth's, and it's pulling in the opposite direction. Both planets' gravitational forces are now pulling at each other at the same time. But that's only on one side of the planet. On the other side of the world, people will actually be 3% lighter right before they die. Thanks, Mars. That's just when people want to lose weight. Now, at the moment of impact, a massive amount of heat is generated, the equivalent of billions of nuclear bombs exploding. After the initial collision, these two rocky planets briefly separate, but that doesn't mean the battle is over. They'll eventually come together again and re-collide. Now, with the amount of heat generated, both Earth and Mars will get liquefied. A shock wave will rock Earth, reverberating through the entire planet, all the way to the other side. Within 20 minutes, everyone on Earth would feel the impact. And everything on the surface of the planet will burn, creating a mass extinction that no living thing could survive. Earth's surface will crack open down to its core. Mars will have broken apart. Large pieces of Mars's core will embed themselves into Earth's core. The entire top layer of the planets will be molten lava, and our two mantles will be mixing together. The energy from the collision will change the speed of Earth's spin. We might spin faster or slower, we don't know. And molten debris from the crash gets ejected into the sky. Smaller bits will fall back to Earth as molten lava, while the larger pieces will start to orbit Earth, forming a ring. Some of the debris will collide with the moon, and some will be ejected further into space, hitting Venus and the asteroid belt. Over millions of years, the debris collisions with the moon will make the moon bigger and heavier. After the collision, part of Mars will be incorporated into Earth. Earth will be slightly heavier. Now, since Mars is 10% of Earth's mass, well, maybe Earth would weigh about 5% more than before. But this new Earth will be devoid of life. Could life ever emerge again on what was once our blue marble? Well, without an atmosphere and without water, it's hard to see how this would happen. Maybe in the future, comets will crash into Earth delivering water, and over billions of years, life might begin again. But with the sun getting hotter and hotter, it's likely going to boil off that water within the next billion years. Prospects for new life on Earth don't look promising.
Welcome to the Void. Black holes remain the most mysterious and destructive force in our universe. And when one explodes, the devastation permanently changes the structure of the universe. But what if not one, but all the black holes in the universe suddenly exploded? Would you die instantly? Or would gravity suck you in? And how could you use this cosmic event to book yourself a journey in time? This is What If, and here's what would happen if every black hole suddenly exploded. In 2016, astronomers discovered the remnants of an explosion from a supermassive black hole almost 400 light years from Earth. The event ripped through space and created a cosmic crater wide enough for 18 Milky Way galaxies to fit inside. This one blast ripped apart the Ophiuchus galaxy cluster and raged for over 100 million years. But what did it take to ignite its fuse? A black hole, which is the remains of a dead star, contains a large concentration of matter squeezed into a tiny area. And its gravitational field becomes so strong that all matter and even light gets sucked into its vortex. The Milky Way galaxy alone contains over 400 million black holes. Yeah, in the center of our home galaxy, there's a supermassive black hole, over 4 million solar masses wide. And studies have found that most galaxies have these gravitational monsters at their core. These supermassive black holes, like the one in our backyard, can expand to billions of times the size of the sun. So, is our galaxy a ticking time bomb? Now, speaking of black holes, 1% of these giants has a swirling mass of gas and dust called an accretion disk. The orbiting debris from this disk falls inside the black hole and shoots out at nearly the speed of light. Guided by twisted magnetic fields, the metals and radiation would burn brightly and return to the cosmos. Debris from the accretion disk endlessly feeds this giant singularity. But what would it take for this behemoth to explode? The black hole would have to take in over 300 million solar masses of gas to create an explosion greater than the one that tore apart the Ophiuchus cluster. And the amount of gas it displaced would equal several trillion suns. Across the universe, the blast would rip galaxies apart and destroy planets. And depending on the amount of gas it took in, the explosion could continue for hundreds of millions of years. Unfortunately for planet Earth, we lay right in the path of a jet stream from Sagittarius A, the supermassive black hole in the Milky Way. super hot particles ejected from the black hole would slam into our planet along with lethal levels of radiation. Once the X-ray and gamma-ray photons reached Earth, they would destroy the ozone layer within months. With this protective layer gone, how long would it take for the radiation to fry the planet? It would take over 1,000 years for those gamma rays to hit our planet if the closest black hole, HR 6819, exploded. So, while we might see several hundred new bright spots in the sky, it would take a millennium before our planet would feel its effects. I mean, if we're still around. This cataclysmic event wouldn't destroy the entire universe, just large parts of it. But the same materials left behind from the blast would create the seeds for new life. Over hundreds of billions of years, these particles could become new stars, galaxies, or even life. On Earth, time near the edge of the black hole would appear to last billions of years. And near the border of the singularity, an object would seem to hover there endlessly. Whoa, watch your head! Some seriously big asteroids are crashing into Earth. What kind of shapes and sizes do they have? Which ones would have the deadliest impact? And which one would be most likely to hit us? Uh-oh, get your bunker ready. This is What If, and here's what would happen if the largest asteroid hit Earth. Okay, let's get the terminology out of the way. I say asteroids, but some of the objects on our list are not asteroids. They're comets. Both asteroids and comets are objects in our solar system, but they aren't the same. Asteroids are rocky leftovers from the early formation of our planetary neighborhood. And of the over 1 million that we know of, most orbit the Sun in the asteroid belt between Mars and Jupiter. On the other hand, comets are snowballs made of frozen gases, rock, and dust. They orbit the Sun, and when they get too close, they start to melt. This releases a giant cloud of dust and gas that can be larger than most planets. With 3,000 known comets in the solar system, could a few be ready to turn the Earth into a giant cloud of dust too? Chelyabinsk meteorite. Let's start with a smaller object that has already hit our planet. Meet the Chelyabinsk meteorite. It exploded over Russia in February of 2013. With a diameter of about 17 meters, it was relatively small, but the impact was huge. The explosion had the energetic equivalent of 500,000 tons of TNT. That's about 30 times as powerful as the bomb that was dropped on Hiroshima. It injured 1,200 people and caused enormous property damage. Pretty big effects from a little extraterrestrial visitor. Chicxulub. Moving on to something bigger, we'll go 65 million years into the past. The massive Chicxulub asteroid was likely one of the forces that resulted in the mass extinction of the dinosaurs. It was about 10 to 15 kilometers wide, and its impact crater in Mexico's Yucatan Peninsula measures 180 kilometers wide and 900 meters deep. Whoa! When this asteroid slammed into Earth, it devastated everything nearby. The blast wave sent enormous amounts of rocky material into the atmosphere, and it caused tsunamis as high as 1,500 meters. While all the soot didn't completely block out the sun, it reduced the amount of sunlight reaching the surface of our planet. That seriously devastated plant growth and had rippling consequences on the food chain. Eventually, it caused entire ecosystems to collapse. Oumuamua. Of all the objects that could collide with us, Oumuamua has one of the more interesting shapes. This rocky, cigar-shaped object is about 400 meters in length. NASA classifies it as a comet, but it exhibits traits of an asteroid too. And it doesn't have an attachment to any star system, so we don't know where in space it originates from. In 2017, it passed by the Earth at a distance of 41 million kilometers. Now, while we were safe from impact on that occasion, it could have resulted in a lot of destruction. If this interstellar guest crashed into Earth, darkness would cover our planet. And if the dust and debris stayed in our atmosphere for a long time, it would kill many plants, animals, and humans that depend on the sun. Bennu. Bennu is not only an asteroid you should worry about, it's the asteroid you should worry about. It has a 1 in 1,700 chance of colliding with Earth in September of the year 2182. At only half a kilometer wide, it's relatively small, but remember how significant the Chelyabinsk impact was? Yeah, with that in mind, you might be a little nervous when it makes a close approach to Earth every 6 years. Shoemaker-Levy 9. This next comet doesn't have any chance of hitting Earth. That's because it already collided with Jupiter in 1994. But you could imagine the destruction this 1.5 to 2 kilometer wide comet would have caused on our home turf. It broke into 20 pieces as a result of Jupiter's gravity. The collisions from these fragments were so powerful that they were similar to the detonations of about 300 million atomic bombs. Plumes of debris shot as high as 2,000 to 3,000 kilometers. And the atmosphere heated to scorching temperatures of 30,000 to 40,000 degrees. You must be pretty relieved that Shoemaker-Levy 9 never hit us. Ceres. Last, but far from the least, is an asteroid so big it's technically classified as a dwarf planet. Ceres is the largest object in the asteroid belt. It makes up 25% of the belt's total mass. The radius of Ceres is 476 kilometers. That makes it over 60 times larger than our ancient friend Chicxulub. If Ceres collided with Earth, there wouldn't just be devastation. There would be no Earth. The size of Ceres alone would block out the sun as it approached. And then, the impact would remove 10 kilometers of the Earth's crust. Hypersonic shockwaves would ripple across the globe. Everything in its path would be incinerated and leveled. Nothing would stand a chance of surviving. Our planet would essentially turn into a glowing ball of fire and melted rock. If by some miracle or secret underground bunker you survived, well, you wouldn't last long. Soot in the atmosphere would result in something like a nuclear winter.
I love that guy was crawling out of the rubble with his briefcase. Where are you going, pal? Work? I don't need a briefcase here where I work. In space, no one wants to see your briefs or your boxers. Hey, I may or may not be wearing pants here. Like we saw in those previous videos, space can be deadly. Not always. You wouldn't always be in danger of planets colliding. Remember, there's 25 million miles, 40 million kilometers between us and our closest neighbor. There's not another car on the road for days. Now, some might say Earth is more deadly than space. We're constantly in danger. Car crashes, drowning, guns, quicksand. The struggle is real to get out of quicksand. Actually, they say don't struggle. You'll only make it worse. Stay calm and move slowly. I wish I had some good advice for these next few scenarios. A couple of the scariest ways Earth is conspiring to kill you. Underneath Antarctica's ice, there's a deep, dark secret. Today, we're going to melt all that ice to find out how it would transform Earth. What mysteries lie buried deep under its thick, frozen surface? As the ice melts and sea levels rise, what would happen to our coastal cities? And why might this lead to some unexpected diseases? This is What If, and here's what would happen if all Antarctica's ice suddenly melted. Welcome to Antarctica, the continent that encircles the South Pole. It's 40% bigger than Europe and full of ice. Here you'll find seals, whales, penguins, and the odd scientists doing some research. And on this continent, you'll find an ice chunk the size of Florida. Welcome to the 120-kilometer wide Thwaites Glacier. Its more scary nickname is the Doomsday Glacier. When it melts, there will be a catastrophic rise in sea levels all over the world. Now, this Doomsday Glacier is melting incredibly fast. It sheds 50 billion tons of ice into the ocean every year, and it accounts for 4% of the 9 inches of sea level rise that's happened so far. Some scientists are predicting that the whole thing might melt in decades rather than centuries. But we don't even have a few decades to hang around, let alone centuries. So I'm going to show you what happens if it melts a whole lot sooner, in seconds. In just a few seconds, Thwaites has melted and flowed into the Southern Ocean that surrounds it, and from there into the Indian Ocean, the Atlantic, and the Pacific. Sea levels rise by 60 centimeters around the world. The streets of San Francisco are getting flooded. Miami and New Orleans are also rushed with water. But what's going on? Why did this glacier crack and break away from the rest? Well, there's something going on underneath. Beneath Thwaites is a massive river flowing fast. Melted ice from the iceberg is feeding it. This is happening thanks to geothermal energy from the Earth's molten interior. The melting process starts off slow, but eventually huge chunks of ice break off. This starts a chain reaction, causing more and more ice to break off and melt. And there's more to it than just one river. A whole world of mysteries lies beneath the ice of Antarctica. But before I take you to that fascinating underworld, I want to tell you about why Antarctica is so important. It's an ice sheet covering an area of 14 million square kilometers, with an average thickness of over 2 kilometers. Just for comparison, that's 1.5 times the area of the United States. That is a staggering amount of ice, 25 million cubic kilometers of it. It's 90% of all the ice on the globe, and locked up in that ice is 60% of Earth's fresh water. Now, unlike the Arctic, where the ice is floating on water, there's land beneath the ice in Antarctica. You don't think about it because 98% of the land is covered with ice. And that's not all. 1.5 million square kilometers of ocean is also hiding underneath this ice. And when all this ice melts in a few minutes, sea levels are going to rise an astounding 70 meters. We'll see what this epic meltdown does to Earth in a bit. But first, I want to show you the bizarre creatures we're discovering inside this frozen landscape. As you explore this uncharted territory, you'll get a peek at the ocean floor, and just above you, you'll see the underside of the ice. Here, you'll find a type of marine life called anemones. These tiny little creatures are burrowed into the underside of the ice. You'll also find some other small fish and crustaceans. The anemones you find are going to be very different from what you'd find normally in the ocean. They're a new species with an unusual trait. See, anemones usually stay rooted to a single spot, kind of like a plant, but these Antarctic anemones wriggle about in the water. Scientists are still figuring out where they're trying to go. Okay, almost nothing grows in that cold darkness, right? So, what are these creatures eating, and how are they surviving? Well, it's probably little bits of plankton and poop ferried in by ocean currents, but they're also eating something that's super weird and kind of gross. It's the ocean equivalent of rotting food in the back of your fridge. These creatures are eating millions-of-year-old rotting skeletons, bodies, and ancient bacteria that were around when Earth was much warmer. Ooh, watch out! A few more massive glaciers are about to break off. As the neighboring glaciers to Thwaites separate and melt, more water pours into the oceans. Worldwide, sea levels rise another 2.5 meters. Cities on the east coast of the United States are covered in water. Boston, New York, Miami, millions of people are affected. Even as cities are getting submerged, something bizarre would be going on right off the coast of Antarctica. Close by, the sea level would actually be falling as all this ice was melting, while the sea level further away would be rising. Now, why would this strange event be happening? Well, remember, the Antarctic ice sheet is enormous. It weighs a mind-boggling 24 billion megatons. So it exerts its own gravitational pull on the surrounding waters, which raises the sea level nearby. But when the ice melts, the power of that gravity is gone, so sea levels nearby fall, just as they're getting higher elsewhere. Over in the east end of Antarctica, the Denmark and Scots glaciers have melted. This adds another 1.5 meters of water to our oceans. Now, at a 4-meter rise, the United States is now losing national monuments. The Jefferson Memorial is underwater, Fenway Park is submerged, major coastal cities around the world are also flooded. Shanghai, Lagos, Mumbai, Jakarta, ports are flooded and destroyed. All that salty water is flowing into farmland and destroying our crops. Even worse, underground aquifers that give us drinking water are now contaminated with saline spilling over from the ocean. What's scarier is that the contamination runs deeper than just salt. The Antarctic ice carries bacteria that have traits that are dangerous to human beings. Some of these bacteria cause infections, and they're linked to diseases like cystic fibrosis. But it gets worse. They have an even more deadly superpower. They're resistant to the antibiotics we use to treat diseases today. If they exchange parts of their genes with the bacteria of our world, the resistance to drugs will only grow and spread to even more bacteria. At this point, we humans would be toast. We'd no longer be able to fight off bacterial infections. Not good if we're drinking contaminated water. But like any Hollywood villain, these bacteria also have a good side. They can help us create new and better antibiotics. They can help clean up toxic waste sites and maybe even be part of a new biodegradable alternative to plastics. As more and more ice breaks off and melts, other ecological systems are getting thrown out of whack. For one, the melting ice is changing the way ocean currents flow. Before all this ice melted, the water in the oceans moved around in a very particular way. Dense, salty water sank to the bottom of the ocean floor, pushing the less dense water up to the surface. Through this movement, the water acted like a giant conveyor belt, transporting heat and nutrients from one place to another. This is a key factor for the survival of marine life. Now, with fresh water from melting glaciers entering the picture, the water at the ocean's surface becomes less salty and dense and doesn't sink down as far. It's like our ocean conveyor belt has been jammed up. It's no longer able to move heat around from one place to another. Scientists warn that the melting of the Arctic will mess with the warm Gulf Stream. They're still figuring out how an Antarctic ice melt will change our climate. Under some circumstances, for instance, if icebergs broke from the Antarctic and melted further away in the Atlantic, the changes in ocean circulation could bring on an ice age. But if the melting primarily caused sea levels to rise, well, we'd probably just end up with a warmer Earth. And it's not just heat patterns that we need to worry about. Breaking the oceanic conveyor belt means problems with the movement of nutrients from the ocean floor to the surface. These nutrients are important for the growth of phytoplankton, tiny algae at the bottom of the ocean food chain. They may seem small and insignificant, but they're the bedrock of life in the ocean. They provide essential nutrients to marine life. But not all phytoplankton would suffer the same fate. For the phytoplankton around Antarctica's waters, the melting ice would provide iron and give them something rich to feast on. In fact, this event might lead to a temporary massive algae bloom as the waters are flooded with nutrients that were previously buried in the ice. The growth of the phytoplankton might be a good thing because at least they'll absorb a little carbon dioxide. The Earth will need that. Why? Well, because all this ice melting is going to make the planet a lot hotter for several reasons. First, ice helps keep Earth cooler through its super reflective surface. It's very effective at bouncing sunlight away from Earth's surface, which helps keep things cool. But once it's melted, that's a different story. With glaciers melting and the water warming, the activity of microscopic fungi in the water is also picking up. Just like dead leaves decompose in forests, microscopic fungi act on dead matter in the oceans, decomposing it and releasing carbon dioxide. Warmer oceans mean more dead matter gets decomposed, leading to more carbon dioxide being released. Now, on top of this, the melting glaciers create a layer of fresh water on top of the salty ocean water. This causes the oceans to be less efficient at removing carbon dioxide from the air, again, adding to the warming. And now, the rest of Antarctica is breaking up into humongous chunks and melting rapidly. Water from the melting ice pouring into the oceans. As the ice melts, something amazing is revealed. A natural wonder that's been hidden for millions of years. An enormous canyon system, 100 kilometers longer than the Grand Canyon. It's the deepest canyon on Earth, running 3.5 kilometers below sea level and stretching all the way from the interior to the coast. And now you can also see the 15-million-year-old Lake Vostok, the 6th largest lake in the world by volume. And good news, with all the ice melted, you can picnic there. If you're still in the mood to picnic after everything the Earth is going through. Plus, you might want to stay away from the microorganisms living in the waters of Lake Vostok. They've been evolving there, isolated from the influences of our world for 15 million years. Who knows what they could do to your body? But there's no time to admire the canyon or peer at Lake Vostok because sea levels are rising, higher and faster than before. You're witnessing the last and most dangerous stretch. Every last chunk of ice is melted. Sea levels have risen over 70 meters. This rapid rise has caught people by surprise. 40% of the world's population, over 3 billion people, live near a coastline, and the vast majority of them have drowned as Antarctica's ice has melted in a matter of minutes. The entire Atlantic seaboard, including huge chunks of the United States, is gone, submerged underwater. People in skyscrapers as high as 23 stories are forced to race to the rooftop in a desperate bid to survive. Parts of California are transformed into bunches of little islands surrounded by water, and other parts of the state are completely gone. London, Paris, Venice, and every major coastal city we know and love is underwater. Millions of people are displaced, injured, or potentially dying from this catastrophic event. Anyone smart enough to jump in their car and flee inland as the water first started pouring onto land may have escaped with their lives if they could get to higher ground, but those are only a lucky few. Governments are in a panic, deploying emergency operations. They know that almost everyone on the coast is drowned, but maybe there's a way to rescue desperate people on top of skyscrapers. But with so many people affected, are there enough helicopters to even rescue these people? Boats would be needed. How will governments be able to replace all the destroyed infrastructure? More importantly, what will we do about the sudden lack of fresh water? With our fresh water mixed with salt water, humans now have a serious lack of drinking water. Suddenly, the land in the interior has become the hottest property. People living in the US Midwest are super happy they were never ever part of the wealthy coastal elite. Denver, Minneapolis, and Las Vegas are looking more attractive than ever before. Now, nations in the southern part of the globe are hit even harder. All of Bangladesh, with a population of 160 million people, is underwater. Geopolitical tensions rise as countries are looking for aid, but since so many places are hit, help is hard to come by. Now that all of the ice is gone, there's still another thing that has to melt: the permafrost. This is the soil that's been frozen at the poles for more than 40,000 years. As it thaws, it releases the carbon dioxide and methane that are trapped underneath it, causing the Earth to warm more and melt even more of the permafrost. As the permafrost thaws, it's as if someone popped a frozen dinner into the microwave. Tiny organisms start to munch on the freshly thawed ancient organic matter. As they do this, they fart out carbon dioxide and methane, which causes global temperatures to rise even more. Great, now we're breathing in microorganism farts and it's getting hotter. Worst scenario ever. Oh, but it can get even worse. In the midst of all this, it's possible that DNA viruses in the permafrost will thaw and kick off a global pandemic. Creating a vaccine in the midst of this catastrophe would be a challenge like never before. Plus, it's hot. Earth is 5 to 10 degrees Celsius warmer. The heat is what's driven the entire ice sheet to melt, but now these changes are making it even hotter. With the average temperature on Earth now almost 27 degrees Celsius, a mass migration of people begins. The most popular spots? Well, Canada, Alaska, and the newly unveiled Arctic and Antarctic regions. These are the new tropical paradises. 34 million years ago, Antarctica was a temperate rainforest like New Zealand. Maybe that's going to happen all over again. Palm trees on the Antarctic coast and alligators swimming in the warm South Ocean. Thank goodness Antarctica is not actually melting in a matter of minutes. With coastal cities turning into watery graves, 3 billion people dead, our groundwater contaminated, more warming on the way, and maybe a global pandemic, I can't think of a worse situation. Unless, of course, land and water suddenly switched places.
Deep under the Earth's surface, there's a scorching hot ball of metal. And scientists just discovered that something very wrong is happening to it. Did the Earth's inner core really stop spinning? What apocalyptic events could this trigger? And are we doomed to become as lifeless as Mars? This is What If, and here's what would happen if the Earth's core stopped spinning. If you were to dig straight down into our planet, well, you'd shovel through 4 distinct layers on your way to the center. First, there's the rocky crust, and that's followed by the hot liquid mantle. 2,900 kilometers later, you'd reach Earth's outer core, made up of liquid iron and nickel. Combined with the solid iron inner core, the 2 core layers of our planet are about the size of Mars. But unlike the red planet, they're scorching hot. At 10,000 degrees Celsius, well, they're hotter than the surface of the sun. And there's also a lot of movement down there. The motion of molten metal in the outer core is what's responsible for generating Earth's magnetic field. Without that, we wouldn't be able to hold on to our atmosphere and we'd lose our protection from dangerous space radiation. And the inner core of our planet is moving too. But new research suggests that it's slowing down to rotate more in sync with the rest of the planet. But slowing down isn't dramatic enough. Let's see what happens when both layers of the core stop moving completely. If only the hot, solid inner core inside the outer core stopped moving, well, you wouldn't need to worry about the apocalypse just yet. The slowing down of the inner core would mostly impact the speed at which Earth spins. It could slow our rotation down enough that our days would become longer, and over time, this could degrade our magnetic field. Yeah, that would be bad news, but not nearly as bad as what would happen if the syrupy outer core stopped spinning too. Without that layer's rotation, well, you'd have to kiss our magnetic field goodbye. And this would put Earth on a course to end up looking a lot like Mars. 4.2 billion years ago, Mars could have been warm enough to have oceans where life might have thrived. But when the red planet's core froze in place, its once strong magnetic field weakened. As the Martian magnetic field degraded, its atmosphere was chipped away by ferocious solar winds, slamming into the planet at speeds of several hundred kilometers per second. That's when the planet transformed into the dry, lifeless desert you know today. But back to Earth. Before it completely turned into a desert planet, well, things would get a little shaky. If the core was to suddenly stop rotating, the tectonic plates would violently slam into each other. It would be a lot like when your bus driver hits the brakes hard and you go flying into the other bus riders. This sudden collision of tectonic plates would cause massive earthquakes along the plate boundaries all around the world. These quakes would destroy buildings, roads, and bridges. Electricity, phone lines, and water systems would be severed. Ultimately, millions of lives would be lost and millions more people would be displaced. Now, as devastating as these earthquakes would be, the damage would just be getting started. With the disappearance of our magnetic field, you'd be exposed to dangerous cosmic radiation that would bombard the surface of our planet. These high-energy particles from the sun would interact with the abundance of nitrogen and oxygen in our atmosphere. And this would destroy our protective ozone layer, allowing more UV radiation to reach the surface. Combining these solar rays and UV radiation would be enormously harmful to all life on Earth. It would damage your DNA, leading to mutations and cancer. And the halting of the core would also make navigating the globe more difficult. Yeah, I hope you have a good trail map for your next camping trip because compasses would be totally useless. All kinds of migratory animals would lose their way too. Birds flying south would get lost and freeze to death, while sea turtles would never find their way back to the beaches that they lay their eggs on. The earthquakes caused by the core suddenly stopping would have already done significant damage to the power infrastructure around the world, but the lack of a magnetic field would continue disrupting things even more. The solar radiation bombarding the surface would damage all kinds of electronic devices and would threaten our power grids. You would end up losing power more often, maybe even permanently. But in reality, you don't have to worry about a catastrophe like this. This study, which implied that the core has stopped and we're all doomed, was a little overhyped. Scientists didn't even talk about the outer core. No, they just meant the inner core, which rotates independently from the rest of the planet. It doesn't stop or reverse its rotation, it just moves slower and faster, like it's done for the billions of years of our planet's existence. Well, good news everyone, we're safe on our big blue space rock. This is one of the largest supervolcanoes in the world. And now it's beginning a massive eruption. But that's not all. At this moment, every single supervolcano is exploding, all around the world. How many supervolcanoes would be erupting? What would it be like to witness so many eruptions? And would this be the end of life as we know it? This is What If, and here's what would happen if all supervolcanoes blew up tomorrow. Before we get ready to rumble, let's just get down to what's so super about a supervolcano. These things aren't just big buckets of lava and ash. They're defined by their colossally huge calderas. These massive cauldron-like depressions can span distances as large as cities like Los Angeles, New Delhi, and Singapore. And when some of these supervolcanoes erupt, they'll spew enough rock and ash to cover entire countries in debris. So if they all went off at the same time, would you have anywhere safe to go? Our supervolcano chain reaction begins in one of California's most beloved national parks, Yellowstone. Known for its breathtaking geysers, this whole place sits on top of a massive supervolcano that could blow at any moment. This supervolcano would explode with a force about 2,500 times more powerful than the eruption of Mount St. Helens in 1980. The sheer explosive power of this would be equivalent to nearly 250,000 megatons of TNT. And plug your ears, because this eruption would be loud enough to be heard across several states. Ash would blanket the horizon, and sadly, most of the national park's wildlife will die in the fiery eruption or its aftermath. Now, before the dust begins to settle on Yellowstone, another eruption will rock the west coast of the United States. This time, the Long Valley caldera would wake up from its 760,000-year slumber. That ancient eruption was so powerful that it created the caldera that still exists today. That is to say, it created the one that existed up until a few minutes ago. Over 1,000 cubic kilometers of debris would burst out of the volcano, sending an unfathomable amount of ash and lava into the air. Next, far across the Pacific, Mount Toba in Indonesia would detonate with a deafening roar. Tropical paradise would turn into pandemonium. And millions of people live close to this volcano, so the death toll from the eruption would be devastating. People all around the world would be breathing in thick, hot volcanic ash. Without a heavy protective mask, this stuff would cause you to choke and you'd be unable to breathe. But this isn't the first time that something like this has happened. The last time Toba erupted, 74,000 years ago, it was one of the most powerful blasts in Earth's history. The vast amounts of material it ejected into the atmosphere caused a so-called volcanic winter, blocking out the sun and leading to a significant drop in global temperatures for the next several years. To round out our look at the chain reaction of supervolcanic eruptions, let's return close to the scene of one of history's most infamous eruptions, Mount Vesuvius. Its supervolcanic neighbor, the Conflagration, would erupt and plunge the Bay of Naples into even more chaos. 2,000 years ago, Vesuvius wiped the city of Pompeii off the map. Today, this supervolcano would threaten the lives of more than 2 million people living in the metropolitan area of Naples. And if the epicenter of this eruption was underwater, well, your Italian beach vacation would be ruined by tsunamis as tall as 30 meters heading right toward you. Now, these wouldn't be the only eruptions happening around the world, but already the consequences would be disastrous. Cities would be plunged into darkness, airports would ground flights all over the world. Even just finding breathable air would be a challenge. The chaos and destruction brought on by all these eruptions would make millions of people homeless. And the numbers would continue to grow as the effects of a volcanic winter settle in. With all the volcanic material in the air, our atmosphere would be filled with sulfuric acid, blocking out the sun. Crops would die, decimating food supplies and leading to mass extinctions of animal species. And just like in the aftermath of Mount Toba's ancient eruption, global temperatures would drop for several years. The one bright spot in this literally dark situation would be that this would significantly reverse the effects of human-impacted global warming for a while. And there would be hope that in the aftermath, civilization might join together to figure out ways to keep life going. Overnight, our planet has gone from a pale blue dot to a glistening white snow globe. Stretches of Earth have become frozen wastelands that are completely inhospitable. And billions of people have been left unprepared for life below freezing. What changes would our planet undergo? What could we do to combat this global freezing? And would humanity be stuck on a giant, irreversible snowball? This is What If, and here's what would happen if the Earth froze overnight. Earth has experienced several ice ages. During these periods, ice sheets pulse outward from the poles and then retract. But 3 of these freezes, between 580 and 750 million years ago, had such an extreme effect that the ice didn't retract for millions of years. These are known as snowball events. Temperatures reached minus 50 degrees Celsius, and the ice and snow reflected light into space. As more heat was reflected rather than absorbed by the planet, the temperature kept dropping. If you could have seen Earth from space back then, it would have looked like a glistening white ball. Eventually, the Earth thawed. Otherwise you wouldn't be here watching this video, but if everything froze back again overnight, could you survive? Okay, let's start by looking at what new kind of planet you'd be stepping onto. Ice sheets 1 kilometer high would cover the Earth. Even in the tropics, the ice would be as thick as 10 meters. Most of the oceans would be covered in ice. Only near the equator or areas with lots of geothermal heat could liquid water still exist near the surface. Everything would be frigid. It would be so cold that most of life on Earth wouldn't be able to survive, especially humans. People living in cold climates would have warm clothing, but this sudden freeze would be life or death for billions. Imagine living somewhere like Belize, Namibia, or parts of Australia where the temperature never drops below 15 degrees Celsius. If you lived in those areas, you'd be at risk of death from exposure to the cold. The same would be true in many other parts of the world, especially for the poor and homeless or those with inadequate access to housing. All power and energy systems would be disrupted, and with no electricity, billions of people wouldn't have heating. Industries would grind to a halt. Even agriculture or livestock cultivation would be nearly impossible. humans would need to band together to conserve food, energy, and other supplies. You would be ready for living on a giant snowball if you were a scientist based on an Arctic research station. At Amundsen Scott Station in Antarctica, the average temperature is minus 82.8 degrees Celsius. Scientists near the South Pole live in shelters built to withstand the cold and ice. Some even have gyms, greenhouses, a movie room, and a sauna. Life in a shelter, though, would be very confined. You would only go outside for specific tasks. To venture outdoors, you would need layers, a lot of layers. Scientists at these stations wear nearly 9 kilograms of clothing. It takes them about 10 minutes to get dressed. Any exposed skin could be frostbitten in less than 5 minutes. This deep freeze would also make the Earth incredibly dry, as all precipitation would turn to snow or ice. That dry air could make you feel dizzy. You would need to constantly thaw snow for water to drink. And the only way to get around would be with a snowmobile. Or if you're looking for a little recreation, you could try to master kite surfing on snow dunes. But be careful, in Earth's lower latitudes there would be howling winds. This would be another extreme element making life difficult. Researchers still don't know how the Earth thawed from these previous snowball events. Unfortunately, if we wanted to reverse the freeze, we might have to change our thinking about greenhouse gases and global warming. We would need to pump the atmosphere with carbon dioxide and methane. That means releasing pure gas or burning even more fossil fuels. On the other hand, we could use bombs to detonate volcanoes around the world. Volcanic activity is likely what warmed the planet in previous freezes. Bombs and volcanoes and burning more fossil fuels to warm up the planet? I don't think that's going to go over too well. That's a bit too much man-made chaos for my liking. But this next segment is all about chaos, and all of it man-made. Some of it controlled chaos, but really, how much control do you have when you're detonating nukes and antimatter bombs on your home planet? Now, dumping your trash in a volcano could be controlled chaos. I mean, 1 bag of trash wouldn't be so bad. 2 bags, maybe? What's the limit on garbage day? Wait, what day is garbage day around here? What do we do, just jettison it out the back? That's dangerous, don't you know? Did you ever see the movie Gravity with Sandra Bullock?
A volcano is one of the most unforgiving natural phenomenons on Earth. If you were to fall into its magma-filled center, your body would quickly bubble up and disappear without a trace. So, if they're so good at getting rid of things, why aren't we using them to get rid of our garbage? Has anyone tried it before? How would we transport all our trash to them? And what dangers would be involved? This is What If, and here's what would happen if we dumped our trash into volcanoes. Americans alone generate about 254 million tons of trash per year. And although dumping it into volcanoes might sound like the perfect way to get rid of it, it wouldn't be that easy. Volcanoes might look like nature's garbage incinerators, but in reality, they're much more dangerous and unstable, not to mention a lot harder to get to. Would overcoming these obstacles be worth it? Or would dumping our trash in volcanoes just cause even more harm to our planet? The first obstacle in our quest for volcanic garbage disposal would be finding an active volcano that can get the job done. There are only about 1,500 potentially active volcanoes worldwide, and most of them aren't located anywhere near humans, for obvious reasons. That means getting all our trash to an active volcano could turn out to be pretty expensive. And once we get there, we might find out it's not even the right kind of active volcano. The kind of volcano we'd be looking for is called a shield volcano. a slow erupting variety that contains the iconic lava lakes that gradually spew out onto the Earth. Unfortunately, these aren't very common. You're more likely to come across their angry cousins, known as stratovolcanoes. Stratovolcanoes are known for their explosive eruptions, caused by the buildup of pressure from hot gas and magma. In other words, they're probably not the safest location for the town dump. But let's say we're lucky enough to find ourselves a nice active shield volcano. Before we worry about the logistics of getting our trash there, let's figure out if it's even a good idea to dump it inside. If you were one of the first waste collectors hired to drive up to the vent of a volcano, you'd quickly start to question your career choices. The vent of a volcano is a treacherous environment full of poisonous gases, lava splatter, and projectile rocks. And things only get worse once you start throwing stuff inside. In 2002, a group of Ethiopian researchers threw a 30-kilogram bag of trash into a volcano, and the results were explosive. Lava lakes are unstable, so if you pierce their surfaces with something cold like trash, you'll trigger a chain reaction of explosions involving pressurized and acidic steam. So can you imagine how big these explosions would be if you threw an entire nation's trash in there? Well, to put it in perspective, rock falls into lava lakes in Hawaii have sent lava 85 meters into the air, so it'd probably look something like that. Even if you could safely get your trash into the volcano, you'd still have to worry about all the air pollution created by burning our waste without filters. Plus, not all materials will completely break down in lava, which means that the polluting remnants could erupt out and contaminate the surrounding landscape. Not ideal if you were hoping to burn nuclear waste, for example. Add these environmental impacts on top of the fact that shipping all our trash to these volcanoes would significantly increase the carbon footprint of the waste disposal, and the whole thing looks like a terrible idea. If we're going to burn our trash, why not at least do it someplace where we can use the heat released through incineration to create new sources of energy?
It's the end of the world as you know it. Every human on Earth suddenly went extinct. And it's time for nature to make its ultimate comeback. What would happen to your home and your city? Why would this doom the planet to a nuclear meltdown? And would any trace of human existence manage to live on? This is What If, and here's what would happen if humans suddenly went extinct. Whether it was a global pandemic, a planet-wide volcanic event, or a gigantic space rock, we reached the end of the line for our species. Every single human on Earth is gone. For good. Now, while there's no hope for humanity to make a comeback, we'd be leaving behind a lot of stuff. Cities, highways, waste. Time to see just how long it would take for the last remaining traces of human life to disappear. The first week of life on Earth without humans would be tough for all the pets. Without you, your furry companions would need to get outside and find food for themselves. So hopefully you left a window open for them. Your peace lily would stand no chance. But that wouldn't be the only thing at stake with you gone for just 1 week. Soon, the world will become radioactive. The thing is, our nuclear plants produce nuclear waste. These pools of spent nuclear fuel need to be constantly cooled off with water. And that water needs electricity to circulate. Without humans to maintain the electrical infrastructure, soon nuclear facilities around the world would start losing power. And that would cause a disastrous chain reaction. The water that used to cool down nuclear waste would stop running and begin to boil off. This would expose nuclear waste, causing it to catch fire. All this waste would explode, covering the planet in deadly radioactive chemicals. Ecosystems around the world would start dying from all the radioactivity. And many of these chemicals would remain dangerous for 300 years. And some, like plutonium, would stay radioactive for the next 240,000 years. But let's not get too far ahead of ourselves. Okay, about 1 year after we're gone, nature would begin to reclaim our roads and highways. Moss and fungus would grow everywhere. And when the first winter hit the planet, these roads would start to crumble. All the freezing and thawing would cause water from melted snow to flow into the cracks. In these cracked, vacant streets, new plants would grow. There would be weeds like mustard and shamrock. And in a few more years, grass. In forests, poisoned by radiation, there wouldn't be any birds singing this year, but further away from these deadly areas, animal populations would start to boom. There wouldn't be any humans to hunt them or force them out of their natural homes anymore. Without pesticides, insects would reproduce quicker, taking over the globe. This would mean much more food for all kinds of animals, like reptiles and rodents. Okay, fast forwarding a bit, you'd start to see our empty cities undergo major changes. London's Trafalgar Square would be growing young trees. Berlin's Brandenburg Gate would be surrounded by forest. In New York City, a lot would be going on underground. Half a century would have gone by since the last time anyone from a maintenance crew managed any of its 753 subway pumps that prevented rainstorms from flooding the rails. There would now be a network of underground rivers below New York's concrete landscape. Steel columns supporting the streets above would buckle and create waterways through Park Avenue and Wall Street. Your abandoned house and your neighborhood would all be in pretty bad shape. Roofs would leak, nails would rust, buildings would start collapsing. In major cities, streets would be littered with glass falling from decaying skyscrapers. All those skyscrapers would crumple into massive piles of rubble. Despite the city being flooded, New York's Grand Central Station and other stone buildings like it would still be intact. And good news, I guess, all your now worthless money would still be safe and sound in bank vaults that would never be reopened. But famous works of art wouldn't be so lucky. Without climate control and electricity, museum vaults would be less fortunate. Water would leak in and mold would cover everything. Ironically, 1,000-year-old ceramics would continue to survive, just like fossils. 500 years later, a forest would now cover where your home once stood. But buried in the dirt could still be the remains of many of your aluminum appliances and stainless steel cookware. Sadly, you wouldn't be around to cook any good meals with them anymore. With every stretch of black asphalt now overtaken by trees and grasses, temperatures would drop all over the world. The atmosphere would undergo changes as it continues to recover. Without humans, there would be less carbon dioxide in it. The initial boom in animal populations from after our disappearance would stabilize by this point. Predators like wolves would once again roam around Europe hunting in packs. Jumping way ahead into the future, would anything remain of human civilization? Well, you'd still be able to make out the faces of former US presidents in the granite of Mount Rushmore, but don't expect many facial features. A lot of the rock would significantly erode. There would also be some remaining pieces of Egypt's Great Pyramid of Giza and the Great Wall of China. But time wouldn't be kind to them, and both would be barely recognizable versions of the former world wonders. At this point, everything that humans left behind on Earth would be consumed by the sun as it expands and destroys the planet. But if you're worried about humanity disappearing into nothingness, well, there still could be a human footprint to be found. The Voyager space probes would be somewhere out beyond our solar system. Maybe some alien civilization would find them and learn that once upon a time, there was human life on Earth.
It's time to live your ultimate supervillain fantasy. Today, you're going to unleash your masterpiece of mass destruction, an antimatter bomb. How would you build it? How much damage would it do to the planet? And how much damage would it do to your bank account? This is What If, and here's what would happen if we detonated an antimatter bomb on Earth. Okay, so before you finalize any plans to usher in the apocalypse, let's see what we're working with. Imagine subatomic particles had an opposite day. That's antimatter. For example, anti-electrons, also called positrons, are just like electrons, except they have a positive charge instead of a negative one. Antimatter is just matter with its electrical charge reversed. You with me? I know. When do the explosions come in? When a particle and an antiparticle meet, they will annihilate each other in a big flash of energy. This usually happens in the form of high-energy gamma-ray radiation. This all sounds wonderfully destructive, but first, you have to build it. And that's easier said than done. I hope you have steady hands because your main goal would be to keep antimatter separated from normal matter until the bomb is ready to go off. Steady. You want to make sure you don't drop. I'm sorry, that was mean. If you value your life and you want to avoid a premature explosion, you may want to use something called a penning trap. Using the penning trap, antimatter such as positrons will be trapped inside an electric field. Just make sure you keep that trap powered. If you don't, the electric field will stop working, and all your antimatter particles would come into contact with the container walls, which, in case you forgot, is made up of normal matter. You know the rest. But while you are tinkering with the penning trap, we could run into another problem. Even if you managed to pull together all the antimatter on Earth, you would only have 10 nanograms. For perspective, if that amount of antimatter exploded on your fingertip, it would be as dangerous as lighting a match. Okay, that's disappointing.
Huh? I really thought that one was gonna explode.
You came here for explosions, and you're going to get them. Let's say you went on a shopping trip around the solar system and were able to get your hands on half a kilo of antimatter. Think it's going to be enough this time? Well, that amount of antimatter is equivalent to 19 megatons of TNT. Oh yeah, now we're talking. So, is this antimatter bomb going to be the doomsday device you wanted? Well, thankfully, we've got a reference point. The Tsar Bomba is the most powerful nuclear bomb ever created. It also happens to be as powerful as an antimatter bomb containing about 1.1 kilos of antimatter. You might want to stand back. When the antimatter bomb explodes, it will erupt into an enormous fireball, creating a 10-kilometer wide column of dust shooting straight up into the sky. Next up would be the mushroom cloud, reaching 65 kilometers into the atmosphere. So, good news? It's going to do some damage. The bad news is it damaged your bank account even worse. One of the biggest challenges to building an antimatter bomb would be the cost. This is because antimatter is the most expensive substance on Earth. A single gram of antimatter can set you back over $60 trillion. $60 trillion! So maybe you could find another hobby besides blowing up the Earth. Maybe you could use your antimatter knowledge for something good.
AI. No, not artificial intelligence. No, not Allen Iverson. I'm talking the other AI. Alien invasion. That is the other AI, isn't it? Well, alien invasions are some of my favorite things in movies. It's a pretty cool concept, and you can dream up some fantastical scenarios between aliens and Earthlings. You know, invasion is a bit harsh sounding. It's not necessary that the aliens would be here to conquer us. It's likely, but it's not necessary. They may have made their way here to share their knowledge with us, give us the old Vulcan mind meld, and we can understand everything that they understand. Or maybe they're here to initiate interstellar trade. What kind of tariffs would the current president of the United States slap on interstellar goods? He knows we're the ones paying the tariffs, right?
Are we alone in the universe?
With more than 100 billion galaxies in the observable universe, and at least 500 billion planets in the Milky Way alone, don't you think we should have found something by now? Even if a tiny percentage of those billions of planets hosted intelligent life, there would be tens of thousands of extraterrestrial civilizations out there. Yet, we haven't seen any. Where is everybody? We keep wondering what's taking them so long to come. But what if I told you that even the friendliest of all aliens could wipe out our entire civilization for good? This is What If, and here's what would happen if aliens visited us tomorrow. We tend to apply our theories to the rest of the universe. We expect aliens to come for a visit, even though we ourselves haven't traveled out of our own neighborhood yet. We just believe that they've had so much more time for technological progress to make space travel possible. So here they are, with their shiny alien spaceship roving above our heads. What would we do? As far as we know, no government on this planet has any sort of alien greeting party planned if aliens suddenly showed up on the horizon. Just try to keep cool. Say the aliens happen to be very polite and sent us a signal before invading our planet's personal space. Well, you wouldn't know it right away. Not until several observatories maintained by different organizations verified that signal. Yep, that's it. Aliens are here, now you know. You got this shocking news from your TV.
NASA officially confirms
An alien ship detected in the solar system, not alone in the universe.
Agencies and countries around the world would be working together, quickly trying to assess the level of threat. They'd summon experts in linguistics, psychology, combat, and biology, and have them attempt to make first contact with the aliens. Groups of experts would record all interactions to analyze simple alien gestures and auditory reactions. Those would help to decide whether aliens came in peace or they intend to do some serious damage. Some people might believe that religious leaders should do all the talking. Something's telling me that aliens didn't learn our languages in school, so good luck to anyone trying to reach out to them. While the world's most intelligent people were busy trying to interpret the aliens' intentions to the best of their ability, You would be, wait, aren't you curious to know what the aliens look like? Some evolution experts agree that things like proteins and DNA are the same no matter where in the universe you're from. If that's true, alien evolution would be close to that of humans. They'd have binocular vision with eyes located close to the brain. Just like us, they'd be based on land and have a minimum of 2 legs for mobility and 3 fingers so that they could handle tools. Still, if some of our own life forms look like this, try to picture something coming from another planet. Meanwhile, on Earth, while governments were busy figuring out the action plan, the media would be keeping you informed. You'd be advised to stay indoors and wait for further instructions. It'd be hard to filter out what's legitimate news and what isn't, but try not to fall for fake end-of-the-world news on Facebook and keep calm. At least make an effort to give up the urge to pack up your belongings and head for the hills. At the same time, the governments and scientific experts would be sharing information about alien interactions. From here, the events could unfold in a few different ways. First, we may not get any auditory or visual response. Nothing at all. This could mean anything from the alien spacecraft doesn't have any aliens on board to the aliens are waiting for their alien backup to fry us up. Another possibility is that aliens responded and tried to communicate with no weapons involved. I can't speak to their possible intentions. For all we know, they may want to get rid of us and keep the Earth to themselves. Thanks to the language barrier, our interactions might not be going well. Tensions would begin to rise. We'd be screwed. Considering that these beings had the technology to travel to Earth, it's likely that they also had the capability to develop some very, very advanced weaponry. Civilians would most likely be hitting the panic button as hard as possible. Meanwhile, governments would put their nuclear weapons on standby. That would be our best and most destructive weapon against them. Or so we think. It may turn out that the aliens have adverse reactions to things on Earth that we're all accustomed to. If, say, their skin melted upon contact with water, then defending ourselves against them would be simple. I'm not saying aliens would necessarily bring doom upon the Earth. They may not mean us any harm at all. But if some hazardous microorganisms from outer space hitched a ride with them and made it into our world, we humans might have no natural immunity to those extraterrestrial microbes, and they could slowly wipe our species off the planet. On the other hand, if aliens weren't coming here to make friends, we'd be destroyed long before we got a chance to offer peace between intelligent beings. In any case, we aren't ready for a visit from interplanetary travelers. We'd better get prepared for first contact.
This just in. Visitors from beyond the stars have arrived. What secrets could our intergalactic friends share? What wonders could these space chums unveil?
They do not come in peace. The aliens have arrived, and they're here to lay down the law. Humans are no longer at the top of the food chain, and we're now at the mercy of our alien overlords. I, for one, welcome our alien overlords. What would our new alien masters do with us? And why did they invade Earth? This is What If, and here's what would happen if we became enslaved by aliens. For centuries, humans have been calling the shots on Earth. Just ask the animals we use as food, keep in zoos, hunt for sport, or even have around the house as pets. We're in for quite the shock when our new intergalactic masters show up and give us a taste of our own medicine. What exactly would they do to us? Well, we may become the new animals. We'd be treated as a commodity to be bought, traded, and sold. And if these aliens are anything like we are, we'd also be their lunch. Human cells are made up of proteins, nucleic acids, and membranes. If the aliens had the same basic biochemistry as us, they would be able to convert our tasty, nourishment-filled bodies into energy for themselves. Would aliens start farming us en masse? What sort of intergalactic economy could be created by using humans like livestock? In China alone, the pork industry is worth $128 billion and has 433 million pigs ready to barbecue. There are 17 times as many humans on the planet. To an alien food connoisseur, would we be just as tasty? Human burger, anyone? What if we were seen as a delicacy to be distributed across the universe? Or what about just pieces of human? Even to us, body parts are a hot commodity. A heart is $1.4 million to transplant and worth $119,000 on the open market. Kidneys are around the $200,000 mark. Livers are $157,000 and bone marrow is $23,000 a gram. We're dealing with human economics here, but this idea can be applied to the concept that we are Earth's new cattle. We're a living organism that might be sold to someone or something somewhere in space. But what if the aliens didn't think we were delicious? What if they thought we were cute? Well, in the US, there are nearly 70 million dogs being kept as pets and 74 million cats. Brazil has 191 million feathered best friends. Would the aliens keep us as pets? Or even worse, what if they kept us in captivity and gawked at us? You know, like we do with animals in zoos. There are approximately 6,000 species in zoos around the world, about 8 million animals in total. The aliens may not have as much variety in human zoos, but we sure are an entertaining bunch. Imagine a group of alien children on a school trip, watching you in your natural habitat. "See, children," lectures the alien headmistress, "the human is on its phone again." So there's not a lot to look forward to. But it makes us think about what the aliens would get out of Earth in the first place. Well, the Earth looks like a nice place to set up shop. On paper, Earth has plate tectonics that help to keep the climate stable, a global magnetic field that keeps solar winds from getting close, and the added bonus of a moon that stops Earth from wobbling on its axis too much. That combination would look appealing to the aliens, and it's something they might have a difficult time finding anywhere else. And what about us? Well, we already know we'd not only be delicious, but profitable. With the aliens having a monopoly on the human market, they could start making more rewarding changes to their new home. Considering that they're intelligent enough to travel light years to get here, how hard could it be to redevelop a planet? The truth is, we don't know for sure what the aliens' plans would be. This is only one of several scenarios that could happen if we faced an alien invasion. There are billions of planets in the universe that theoretically can support life. But so far, we haven't discovered any aliens out there. Maybe the reason is we're just looking in the wrong places. What if alien life isn't anything like the life we know of? What if it doesn't need water or oxygen? What if it can withstand incredibly hot temperatures or very acidic environments? And what would we need to search for to finally find it? This is What If. And here's what would happen if alien life was silicon-based.
There's one thing that your DNA, a diamond, and a rubber duck have in common. They're all made of carbon. In our own solar system. A candidate for hosting a silicon-based alien life is hiding among the moons of Saturn. Titan, the biggest of these moons, has an atmosphere that's 95% nitrogen and 5% methane. It has no oxygen, and any water it has is frozen solid because Titan receives only 1% of the amount of sunlight the Earth does. But silicon-based life forms wouldn't need any water. Instead, they could use liquid methane as the galactic elixir for their existence. The lack of oxygen would also be essential for such life to emerge. Here's why. When carbon unites with oxygen, or oxidizes as it does during a fire, it turns into a gas, carbon dioxide. Now, when silicon oxidizes, it becomes silicon dioxide, or silica, which is a solid and not a gas. If Titan had oxygen in its atmosphere, silicon would immediately turn into rock, and no life could possibly begin in that state. But Titan's atmosphere doesn't contain any oxygen, giving silicon-based life a chance. What would this life look like? How big would the silicon species be? Would they build their own civilization? Or invent their own language? Well, most likely, if there is silicon-based life out there, it would be in the form of microbes, and not animal-sized organisms that you can see with your own eyes. Scientists generally agree that any silicon-based life would need intense heat to survive, so most likely you'd have to dig deep under the surface of Titan to find it. Because of the extreme cold on Titan's surface, a living being would live somewhere close to Titan's core, where it's hot. And hey, there are many planets out there. Some of them might just have the right conditions for non-carbon-based life to thrive. Because silicon doesn't get along with oxygen, the metabolic processes of a silicon-based organism would have to be entirely different from ours. We don't know if it's even possible, just as we don't know if anything strictly silicon-based would have a DNA. But maybe we shouldn't try applying our science to alien life we've never encountered and planets we haven't thoroughly explored. Okay, so we've covered aliens ending us ending ourselves, disasters ending us, and space getting a crack at it too. What's left? Well, like I said earlier, Earth is a dangerous place. It's like Australia, except bigger. In Australia, if a Morton Joe's war boys don't get you, the snakes and spiders and sharks and crocs will. And they grow them big down there. Similarly, for something on Earth to end humanity, well, it'll have to be something big. Some killer creature that evolves from the swamps of Florida or creaks open the sealed doors of the contaminated 3 Mile Island nuclear plant. It's got to be cinematic and scary. Otherwise, we wouldn't make a video about it.
This is the Titanoboa, one of the largest and deadliest snakes to ever exist. It went extinct 55 million years ago, but what if that never happened? What if the Titanoboa just kept evolving and was alive today? What special traits would this deadly creature have? And how big could it get? This is What If, and here's what would happen if the Titanoboa never stopped evolving. Okay, before we look at the modern day Titanoboa, we need to go back. 60 million years ago, the Titanoboa lived in the tropical waters of South America, arriving on the scene after the dinosaurs went extinct. It was a major predator of its time. This snake was unimaginably large. It had a girth of about 1 meter. That means if it were slithering on the ground toward you, it would come up to your waist. It was 14 to 15 meters long, and it weighed over 1,000 kilograms. Luckily, the Titanoboa wasn't venomous, but don't let that trick you into believing it was safe. It had a different way of killing its victims, by squeezing the life out of them. Literally, by wrapping itself around your body or squeezing your windpipe, and then swallowing you whole. And if you tried to slip out, you'd be met with rows of sharp little teeth that would dig into you. But you could see this creature coming, right? No, not a chance. The Titanoboa was the perfect color, a color that allowed it to camouflage itself in its swampy environment. It would sit and wait for the perfect moment to strike. It feasted mainly on fish, turtles, and crocodiles. So, if the Titanoboa was so dominant, what finally made it go extinct? Well, it had to do with a massive change in climate. But to understand this, let's first dive into what made the Titanoboa such a dominant creature, and then how it suddenly went extinct. Paleocene, 66 million years ago to 56 million years ago. Titanoboas emerged after the apex predator niche was left empty by the extinction of the dinosaurs. They thrived in hot and humid environments. Lucky for them, that's what Earth happened to be like 60 million years ago. The average temperature was around 24-25 degrees Celsius. Now, we love that temperature in the summer, but imagine if it were that way the whole year. Instead of ice caps, the poles were covered with forests, and instead of polar bears, there were alligators roaming around. Just like today, a planet even a few degrees hotter is very unpleasant for human beings, so it's a good thing we weren't around at that time. But there's a set of animals that thrive in the heat, cold-blooded ones. Our Titanoboa was cold-blooded, so it loved warm weather. Unlike warm-blooded creatures, cold-blooded animals aren't able to regulate their own body temperature. They use heat from the environment to warm up their bodies and kick their metabolism into a higher gear. So a warmer Earth was perfect for the Titanoboa. It had a supply of external energy to keep its body warm, hunt without mercy, and become one of the largest predators ever. But then the Titanoboa went extinct. Why? Well, a lot of changes were happening at this time. The Earth experienced two very different climate shifts. First, it became very hot, and then it cooled down. With our current evidence, it's not clear if the Titanoboa became extinct during the heat spike or during the cooling phase. So let's look at each change and try and figure out what might have happened. The heat spike event, 56 million years ago. It was 56 million years ago that Earth suddenly got super hot. The official name for this heat spike is the Paleocene-Eocene Thermal Maximum, or PETM for short. Massive amounts of carbon dioxide entered the atmosphere, raising the temperature by up to 8 degrees Celsius. The seas became really hot. In the tropics, it was like a warm bathtub with temperatures around 38 degrees Celsius. There was a mass extinction of creatures in the deep sea. In particular, many single-celled creatures called forams died out. Now, for the Titanoboa, this may have resulted in two different outcomes. It's possible that this giant snake thrived in hot water and became larger. Even if some fish were dying, other reptiles like turtles and crocodiles could have also grown big with the heat and became a great food source for the Titanoboa. So in this scenario, our Titanoboa just gets bigger and badder during the heat spike. But there's another possibility. Maybe the Titanoboa went extinct due to the warmer temperatures. Because the heat spike was so sudden, oceans absorbing carbon dioxide would have become more acidic. Many fish may have died in that acidic warm water, which would have meant fewer fish for the Titanoboa to eat. Now, if this were the case, the Titanoboa would have needed to adapt to survive. What evolutionary change could have helped it survive this heat spike? Well, if the tropical waters were too hot and acidic to live in, moving onto land would have been Titanoboa's best bet. Yeah, switching from a mostly pescatarian diet to being a meat eater. Now, as Earth became warmer, something interesting was happening. Above the waterline, the land was exploding with different types of mammals. Camels, horses, pigs, goats, and giraffes all evolved when Earth was a giant sauna. So, if Titanoboa moved from water to land, it would have found some new foods to keep it going. But because of its large size, living on land would have been difficult. So, our Titanoboa would need a different kind of adaptation to get through this temperature spike. The giant snake is going to get some stronger swimming muscles and swim up to the poles, because now the poles have warmed up so much that they're tropical. The ice melted into water, and the polar seas were full of crocodiles, the perfect lunch for a hungry Titanoboa. Eocene and Oleocene, 56 million years ago to 23 million years ago. Okay, after 200,000 years, the heat spike was finally over, and temperatures went back to what they were before. But another major shift in climate is on the way, a cooling. Around 50 million years ago, temperatures began dropping in a long-term cooling trend that lasted until the dawn of civilization. The once lush forests at the poles are now becoming ice caps. This was bad news for the Titanoboa. The cooler climate didn't suit this cold-blooded snake. It could no longer get the heat it needed from the environment to be able to power itself. It's possible that this led to the Titanoboa's extinction about 55 million years ago. In order to survive, it would have had to evolve in a different and totally unexpected way. In our hypothetical scenario, the Titanoboa becomes warm-blooded. Maybe you're thinking, well, can a cold-blooded animal really become warm-blooded? Well, how is that even possible? Well, it's true that if we look at snakes, we don't see any examples of them being warm-blooded, but there is another category of cold-blooded creatures that have some warm-blooded exceptions. Fish. While the majority of fish are cold-blooded, about 0.1% are partially or fully warm-blooded. For instance, the moonfish is warm-blooded. Bluefin tuna, white sharks, and salmon sharks are kind of both. They use a special mechanism to raise their body temperature called vascular countercurrent heat exchange. Let me show you how it works. Let's use a shark as an example. Now, the muscles they use to swim generate heat, which heats blood in the veins. The arteries bring cold, oxygenated blood from the gills to the shark's muscles and organs. This cold blood picks up the heat from blood in the veins, which then raises the shark's internal temperature. But in the Titanoboa's case, there are no gills involved. It breathes in through its nostrils and has lungs to supply it with oxygen. But we can make it warm-blooded like the shark by having cold blood pumped in through the arteries, which then pick up the heat from the warm blood in the veins. This single evolutionary transformation would allow the Titanoboa to survive the mass cooling. Let's see what happens next. Miocene. 23 million years ago to 5 million years ago. During the Miocene epoch that followed, Earth began to warm a little, followed again by a period of cooling. The climate became drier and vegetation was more coarse. Rhinos were dominant in North America. Many species of horses evolved, as did a variety of camels. Also, a saber-toothed cat-like creature called the Nimravid roamed around. Could the Titanoboa have adapted in new and different ways to spawn a line of desert Titanoboas? Yeah, I know I said that living on land would be tough for such a massive creature, but maybe there's an evolutionary path to make this possible. To camouflage in the desert, it would need to adapt a new color scheme, a light sandy color. And its next most important adaptation? Strong muscles to burrow into desert soil and live underground during the day, both to conserve energy and to hunt under the cover of darkness. Now, to protect against water loss through the skin, the Titanoboa would take a lesson from the spadefoot toad. This toad secretes a semi-permeable membrane that makes its skin thick, locking in moisture. Our desert Titanoboa would branch out and have a new diet of birds and mammals. Many desert animals are too small to make a meal, so Titanoboa would lie in wait for a herd of camels, slither out of its burrow and make a killing. Or it might go months without food. So the evolutionary path of Titanoboas could lead to two subspecies. The first one is shark-like, swimming far and wide across the ocean, able to preserve its body heat through adaptations that make it warm-blooded. And the second is also warm-blooded, but lives in burrows deep in the desert, like the sandworms from Dune. They emerge from the burrows with lightning speed, only to strike, eat, and then retreat back underground. These 21st century Titanoboas would be as long as 23 meters and about 1.2 meters wide. Imagine going for a swim in the ocean and running into one of those. You'd have just enough time for one last breath. 6,000 years ago to today. Now, this brings us to the question of how modern-day humans might interact with these magnificent and terrifying creatures. Before the start of modern hunting, Titanoboas would have been legendary, frightening sea creatures that terrified humans. Our ancestors would probably be scared of going in the ocean. Who knows? Any swim could be your last if you encountered a Titanoboa. The only good news would have been that these enormous creatures would probably have little interest in eating you. Because humans would provide little sustenance, they'd rather catch a large fish or crocodile. That would be much more satisfying. Now, as humans developed better weapons, the relationship would have changed. There's evidence of humans hunting whales as far back as 6000 BCE. If the Titanoboa was still around, it may have been a target of fishermen thousands of years ago. Maybe these snakes would become part of our diet. If their meat was tasty, who knows? Maybe humans would have hunted them to near extinction by now. In today's world, it'd be a lot like the occasional shark attack. We'd probably hear about rare Titanoboa attacks on humans who swam too far out into the ocean. In the desert, nomadic tribes would probably fear the random, unpredictable attacks of the desert Titanoboa. Camels would have evolved to be super sensitive to those giant snakes' underground movements. Maybe they'd warn humans when they sensed activity underground. With infrared technology, we'd be able to detect the heat signature of Titanoboas in their underground burrows. Future. But in today's fast-changing world, something new and interesting would be happening. Human activity has reversed the cooling trend. With global warming, temperatures are becoming attractive for reptiles again. Our newly evolved Titanoboas have a warm-blooded inner architecture that has helped them survive the cooling of prior epochs, but as the Earth heats again, the Titanoboa would, once again, lean on the environment for heat rather than using its muscular inner activity. Conditions would be ripe for the Titanoboa to hunt even more effectively and grow bigger. As sea levels rise in future years, our coastal cities will be flooded and destroyed. The warm weather will help new generations of Titanoboa thrive. But the traditional habitats of the Titanoboa are currently being destroyed. The lush tropical swamplands and forests near tropical waters are being wiped out by logging and commercial activity. The growing acidification of the waters will kill the marine life that the Titanoboa feeds on. This would prove to be the biggest challenge for the creature, the destruction of its food supply. But there is one prey left for the Titanoboa. It would have to eat several to make a meal of them, but there's lots around. You guessed it, I'm talking about us. Maybe we'd become the target of the new ferocious Titanoboa. Watch out the next time a coastal city floods.
How cool would it be to see a real-life T-Rex? If only that one fatal asteroid never hit the Earth. Would dinosaurs still be alive today? Would they have evolved? Would humans have survived this long? Could we ever learn to coexist? This is What If, and here's what would happen if dinosaurs never went extinct. Until 66 million years ago, dinosaurs of all shapes and sizes roamed the Earth. Intelligent, adaptable, and sometimes weighing as much as 2 jet planes, it's hard to believe that it only took one rock to wipe them all out. Of course, this was no ordinary rock. The asteroid that took out the dinosaurs was 9 miles wide and hit Earth with the destructive force of 10 billion Hiroshima bombs. The radioactive shockwave obliterated everything for hundreds of miles in every direction, and 75% of all species on Earth went extinct. If that asteroid had hit just a little earlier, a little later, or even a few miles off course, we would be living in a very different world today. The rock that killed the dinosaurs struck the shallow waters of Mexico's Yucatan Peninsula. Had it landed a little farther off the coast, in a deeper part of the ocean, the water might have absorbed some of the blast, along with its devastating effects on the atmosphere. But even if the asteroid missed the Earth, dinosaurs would have to survive several significant global events in order to make it to the present day. 55 million years ago, temperatures rose. The climate was 8 degrees hotter than it is today. Rainforests sprouted, and vegetation flourished. Herbivores would have adapted and thrived, but they'd have started to look a little different. The plants of this period were less nutritious and easier to digest, meaning dinosaurs would likely shrink in size, since their new diet wouldn't have as much energy. Roughly 20 million years after that, South America and Antarctica split, creating a cooler and drier world climate. During this period, long-legged, fast-moving dinosaurs would have evolved to travel the huge grasslands stretching out across the globe. Compared to mammals of this period, dinosaurs held significant advantages, such as having more teeth and better eyesight. Considering the dinosaurs were already so advanced, scientists wonder whether mammals would have evolved at all if dinosaurs hadn't gone extinct. It's likely that the big animals we know today would have been prey to dinosaurs. But remember, humans evolved alongside woolly mammoths and saber-toothed cats. While those species didn't survive the ice ages of 2.6 million years ago, given the evolutionary traits of some dinosaurs, there's a chance they might have persisted. But what about us? Could we handle freezing temperatures and huge, terrifyingly vicious predators? They say running keeps the body warm, but that might also make you taste better. In an alternate universe, if we did survive alongside these prehistoric beasts, it's possible we could see a real live T-Rex on a protected reserve, not unlike Jurassic Park. Human population growth and excessive hunting would have driven larger dinosaurs to near extinction. Today, they would most certainly be an endangered species, but those that shrank and adapted over millions of years could coexist peacefully among us. In fact, some actually do. Where do you think pigeons came from? It's hard to believe that birds were once the size of biplanes, but then again, it's hard to believe that with a slight twist of fate, we might have walked with dinosaurs. Or we might have become dinosaur chow and not have evolved at all.
They can endure the cold reaches of space, go without food or water for up to 30 years, and are nearly indestructible. But they're like really tiny, so there's not a whole lot we can do with them. However, what if tardigrades were the size of humans? How could we use them? Would we live in harmony? Or are we no longer at the top of the food chain? This is What If, and here's what would happen if tardigrades were the size of humans. This is a tardigrade.
You can call me Tardy, but I'm always on time.
Yeah.
Kinda looks like an 8-legged bear, doesn't it? Well, an 8-legged bear from your nightmares is more accurate. While only measuring in at 1.2 millimeters max, these guys are as tough as nails. Tardigrades are classified as extremophiles.
What a file?
Whoa.
This means that they can roll with the punches in whatever extreme environment they call home. They can go 30 years without food or water, thrive in an absolute zero or above boiling temperature, and survive in pressures 6 times that of our ocean's deepest trenches. These teeny tanks can thank a unique protein for their resiliency, known as DSUP, which is short for damage suppressor. So, what would life be like if tardigrades had a growth spurt? Well, picture this. You've got a nice little pond in your backyard. It's quaint, relaxing, and really brings the whole yard together. Well, freshwater sediments like your pond may have as many as 25,000 tardigrades per liter, or almost 100,000 of them per gallon. But now things aren't as cozy. Imagine taking a look out your window and seeing 25,000 human-sized tardigrades dogpiled in your backyard. Our planet would be swamped with giant tardigrades. Okay, there's got to be a plus side to this. Maybe we could use them for something. What if you rounded up a posse and went hunting for tardigrade? Could we use their hard outer hides to create protective wear and get some of that sweet, sweet desup for ourselves? Tardigrades are encased in a rugged, flexible cuticle. Imagine a cow with armor similar to the exoskeletons of grasshoppers. Maybe the military could use this pliable yet sturdy material for some heavy-duty tardigrade armor. Nah, those are some cool ideas, but remember what I said about them being extremophiles. Yeah, they're not going down that easy. They don't even care about things that would give humans a run for their money. Take droughts, for example. A dry environment might trigger a tardigrade to go into a cryptobiosis state. The tardigrade will squeeze all the water out of its body, retract its head and limbs, and roll up into a little ball and become dormant. This is known as a ton. When in this form, the tardigrade's metabolism slows to 0.01% of the normal rate, and it can maintain this halted state for decades until it again comes into contact with water.
What the? Hey, cut it out!
So, now that they're asleep, you might be thinking it's the perfect time to attack. Well, we wouldn't recommend it. A giant angry tardigrade has 8 legs and 4 to 6 claws on each paw, not to mention their dagger-like teeth that also make them ferocious killers. Now, thankfully, we don't have to worry about our planet being overrun by human-sized tardigrades, but that doesn't mean we can't still learn from them. Because they are so resilient, we could gain a thing or two from these tiny titans, such as how to develop more resilient crops by using their valuable DSUP protein. I guess we could count ourselves lucky that if tardigrades were the size of humans, they'd be like big, lumbering cows, so at least they wouldn't be flying around us, dive-bombing our heads.
66 million years ago, a giant asteroid struck Earth, wiping out the dinosaurs and 75% of the other animals on Earth. Devastating, yeah, but this was millions of years ago. What if this asteroid were to collide with us today? Is there any chance we could stop it? What parts of the world would be most impacted? And why might this end up being a good thing? This is What If, and here's what would happen if the dinosaur-killing asteroid struck in 2024. Okay, let's see what kind of asteroid we're dealing with here. Known as the Chicxulub impactor, this asteroid was as wide as 100 to 200 football fields. That's 10 to 20 kilometers wide. And now it's coming directly toward us, specifically the Yucatan Peninsula in Mexico. If you think you can run away from this thing, yeah, no chance. It's hurtling toward Earth at 20 kilometers per second. Suddenly, it crashes into the sea, killing everything in the immediate vicinity. But that's not all. A thermal pulse radiates out from the blast site, releasing the energy equivalent of 10 billion nuclear bombs. Cue an enormous shockwave of air that destroys everything within 1,500 kilometers. Plants and animals are shredded, forests burn to the ground. A magnitude 10 earthquake would crack the earth open. Quakes would radiate throughout the United States. Massive tsunamis would rise. Mexico City, Florida, and Texas would all feel the effects. I know Texas has talked about seceding, but I don't think this is what they had in mind. Now, although there will still be life on Earth, it might not last much longer. Plumes of dust and sulfur in the atmosphere block the sun. For the next 15 years, it's a cold, dark, awful winter. Only a few of us will make it out alive. But maybe the humans that do survive will be able to rebuild Earth. And funny enough, that massive asteroid that caused all the damage, well, it might hold the key to a stable new future. If you want to see what I mean, let's head to the impact site. Some of the most valuable materials known to humans are scattered within this massive crater of destruction. This asteroid, like many others, contained one of the most essential elements for rebuilding our society: gold. Now, when most people think of gold, they think of it as a symbol of luxury and high status, but they don't understand why it's considered to be so valuable. Well, for starters, it's a key component we can use to rebuild our communications technology, energy infrastructure, and medical equipment. But more importantly, if traditional currency systems collapse after this disaster, it would help stabilize the global economy. Gold has been valued as a stable medium of exchange and store of value for millennia, especially during difficult times. Even in today's volatile market environment, gold remains one of the safest investments. With a 1-year return of 8.68% and a 5-year return of 54.95%, gold continues to show its resilience and capacity to protect investments against inflation, currency devaluation, and geopolitical risks. According to experts at Calibre Mining, a public company that produces gold listed in Canada on the TSX and in the US on the OTCQX, gold production remains underinvested despite its value. Let me explain. Calibre Mining leverages the stability of gold with the added potential of a high-growth company. They've proven value through delivering 28% year-over-year production growth and even a 10-fold increase in their reserves since 2019. With 5 mines across the globe and the ability to self-fund exploration, well, Calibre is constantly drilling and finding more gold. They continue to grow and diversify their gold production with their new Canadian asset Valentine gearing up to come online next year. Now, despite that success, gold and gold production is a sector not getting much attention yet. But the price continues to rise, and well-known banks like Goldman Sachs predict higher prices. So you can see why having this giant deposit of gold in front of us is one of the most useful things we could ask for when rebuilding our society. And mining from it will continue to provide value and wealth for future generations. But for any of that to happen, we need to survive the asteroid in the first place. And luckily for us, it's not 66 million years ago. It's 2024, and we're Homo sapiens. Creatures with really big brains and bright ideas. No offense to the T-Rex, but they definitely weren't getting Wordle in 2, and they definitely weren't tracking the sky for asteroids. But there's a team at NASA doing just that. And if we were able to spot an asteroid ahead of time, could we somehow steer it off course? Well, it's possible to deflect an asteroid from its path. Here's 5 different options we can explore. The first possibility is a kinetic impactor. This is the only deflection option scientists have tested so far. The idea behind it is to violently slam an object into the asteroid, pushing it off its path. NASA tested this technique in 2022 by slamming a spacecraft into Dimorphos. Dimorphos is the moon of a near-Earth asteroid, and thanks to the force of the collision, it's now going faster. So, in theory, we could use this option to move an asteroid off course. But there's a bit of a problem. The asteroid we're dealing with is way too big. In order to successfully knock it off course, we'd need multiple kinetic impactors. I'm not liking our chances with this one. Let's see what else we got. Okay, the second option for deflection is called a gravity tractor. Think of this like your dog pulling on its leash, taking you down a different path to smell something interesting. Minus the dog and the smell. Here, a spacecraft flies next to an asteroid, changing its path by the force of its gravity. Unfortunately, there's a big problem with this method. Well, for starters, it takes a really long time, and again, it only works on small asteroids, ones that are less than 500 meters in diameter. Yeah, this will be a no-go when it comes to the massive asteroid heading toward Earth. Okay, the third option is something known as an ion beam shepherd. But instead of herding goats, this shepherd is a spacecraft herding the asteroid out of our way. The spacecraft has an ion engine which generates an exhaust of accelerated xenon ions. These ions are super powerful charged particles, and the force of these charged particles deflects the asteroid, but probably not powerful enough to deflect a Chicxulub repeat. Okay, next up, space lasers. Now, if you're imagining zapping the entire asteroid with lasers so it vaporizes, no, that's not it. Unfortunately, it isn't as cool, but it can be effective. The laser is trained on the surface, creating plumes that push the asteroid away. And if we had enough lasers that were powerful enough, this might be a viable method. Finally, for a really big asteroid like the one we're dealing with here, and something's got to be done, there's always nukes. Now, this would be incredibly dangerous because there's always the possibility of fragments of the asteroid or other space debris falling on Earth. Not to mention, launching nukes in general is a super risky endeavor, but let's be real. An emergency like this probably justifies us unlocking the nuclear codes. Scientists tell us that sending a nuke that detonates next to an asteroid 2 months ahead of time could vaporize 99.9% of the asteroid's mass away from Earth. Sounds pretty good to me. Now, all of this only works if we spot the asteroid way ahead of time. If for some reason we don't, and an asteroid suddenly came out of nowhere, we'd have a mass evacuation. The evacuation zone would be determined based on the size, speed, and angle of the impending impact. Since it's hitting the Yucatan Peninsula, well, the US, Cuban, and Mexican governments would be busy evacuating people in Mexico, Cuba, and parts of the southern United States. The three governments would have to create alternative arrangements for food and shelter for hundreds of thousands of people, maybe more. Now, mass evacuation doesn't sound like a walk in the park, so is there any upside to having an asteroid land in our backyard? Well, yeah, there are amazing gifts the asteroid could bring us. A whole host of valuable minerals. Due to their highly inconvenient locations in deep space, like in the asteroid belt, these space rocks are extremely difficult to mine. But this would change if an asteroid landed on Earth. Just a single asteroid is estimated to contain a ridiculous amount of gold. 700 quintillion. That's enough zeros to give every person on Earth $93 billion. And there are other elements that we might be able to extract as well. Cobalt, platinum, nickel. In fact, the pressure with which the asteroid crashes can transform one element into a more valuable one. For instance, at a meteorite crash site in Australia, a rare mineral, rhyodite, was found. It was formed out of zircon as a result of the high pressure and temperature of the impact. And, mining these elements from asteroids could free us from the human rights issues that have been part and parcel of traditional mining. Caliber mining follows ethical mining practices, but not every mining company does. In addition, mining asteroids would be more environmentally friendly, free of the danger of releasing toxins like lead and arsenic into our water. Today, large impact craters in South Africa and Canada are already being mined. They're rich sources of nickel and gold. The devastation from the crash of an asteroid would be horrific, but if it turns out it's unavoidable, that devastation may hold the clue to new resources and new growth. But this is what would happen if the Chicxulub asteroid hit Earth. Now, what would happen if an asteroid hit the moon and cracked it in half? Well, that sounds like a story for another What If. Hey, welcome to another of our fantastical, far-reaching, and yet comfortingly hypothetical trips through our world and beyond. Today's marathon of what-if scenarios includes, of course, a look at several thousand different ways that our universe could decide to end us, or unalive us, as the kids say.